Hey, good morning, grade nines. Okay, well, I wanted to talk to you about lesson four, which is called water quality and monitoring water quality. And one of the things that we look at when we look at water quality is, like, if you were going to bring your water in for a sample, what kind of things would you look at? Well, one thing you look at is turbidity. Like, turbidity means like how cloudy is it? If it's cloudy water, even if it's good quality water, you look at it and go, ugh, it's kind of cloudy. Well, that's because it's got a whole bunch of dissolved things in it. That doesn't necessarily mean it's bad. But that's one of the indicators of quality of water. So turbidity is one thing. But another thing is when we look at the quality of water is especially if we're looking in a pond, for example, we look at like what's in the water. So those are called biological indicators. So if it's got a healthy variety of like fish and bugs and a whole bunch of different varieties of things, living things, organisms that are living in there, it's probably a fairly healthy water source. If you only find like one kind of bug in there, like for example, you find slugs in it, that's it. It could be an indicator that it's not a very healthy water source, and in fact, maybe it's lacking oxygen or things like that. So there's a couple things that we look at. We're looking at lab tests for those kind of things. We're looking at things like pH. pH is one of the things that we test for, or acidity. How acidic is the water? Fish and other bugs can only survive in water that's got a reasonable pH. Most of the range that we're talking about, things that can live in pH, is about 6 to 9 sort of thing. That's kind of the range that things can live in. More acidic than 6, you probably won't find a lot of fish. More basic than 9 or alkaline than 9, you probably won't find a lot of fish either. So acidity is one of the things that's going to happen. And as the pH decreases, fish, etc., will start to disappear. Another thing is dissolved oxygen. And obviously that's important because fish and other organisms breathe oxygen. So dissolved oxygen is another indicator. So how much oxygen is in there? And you can actually test that. Fairly simple. And it depends on the temperature. And the interesting thing is that the more turbulent the water is, the more dissolved oxygen there'll be. This is one of the reasons why at Rotary Park we have that windmill thing that's in Rotary Park. There's a little turbine underneath, and as the windmill turns, it turns the water around because Rotary Park is fairly still. And in order to get oxygen for the fish, etc., you got to be able to turn the water up. And that's why, like, you need an air. If you have a big fish tank, you'll need like an air pump in there to pump water down, because you can probably appreciate that if you have a fish tank, the only place that the water is going to be exchanging oxygen with in the air is the very top. So that means there's no oxygen down here, so a lack of oxygen down here, and that's where fish live. So you have to churn that up. Flowing water like rivers, etc., have quite a bit of oxygen in them, but lakes have less. So dissolved oxygen is another one. Another thing that we test for are heavy metals. Things like mercury, lead, things that build up in the environment that are heavy metals. Very dangerous metals. Now, the unfortunate thing about heavy metals is if you look at the Athabasca River report, when you open up your fishing guide, it says right in there that pregnant women should not eat fish out of the Athabasca River due to heavy metals in there from industrial processes from mills, etc. Because those accumulate and they don't go away. So really kind of sad is that, you can have, even though you have regulations on how much you can put into the water, that accumulates. And we now know that. So there's areas, so pregnant women shouldn't eat fish from there. Most people shouldn't eat more than 4 fish per week out of the Athabasca. Kind of sad. McLeod's a totally different thing, much cleaner river, but that's kind of sad that one of our major rivers in Alberta is polluted with heavy metals to the point where people can't eat of it. But check the fishing regulations. Don't believe me, check it out. So those are heavy metals. Another thing is presence of pesticides. Are there pesticides in the water? And this is, of course, mainly from, if we look at herbicides, if we have farmland here and we have a river here, there's going to be runoff off the farmland from fertilizers, etc., that end up in the river. And these cause what are called algal blooms. They cause the algae in the river to grow like crazy, or in the body of water to grow like crazy, and they suck up all the oxygen out of the water, and then very little can live there. So that's called, when we have a lack of oxygen in there, that's caused by runoff. So sometimes that lack of oxygen is caused by presence of pesticides. Okay, so those can be bad things. The next thing you want to think about is, that I wanted to talk about the content that's really, really important, is called toxicity. And toxicity is determined by, or describes how poisonous a substance is. And what we look at when we look at toxicity of a substance, we look at what's called the LD50. And what the LD50, it's an incredibly important concept. And what it is this is the lethal dose of whatever substance that will cause death in 50% of the population. So any pollutant, any environmental impact pollutant has an LD50. So DDT is one of the worst. And the lower the LD50, the more dangerous the chemical is. So what that means then, let's say the LD50 was, 0.001 parts per billion. And we'll talk about parts per million, parts per billion here in a bit. That's a very, very small amount for an LD50. So that doesn't require very much chemical in order to cause a death in 50% of the population. So let's say, for example, you had 50 or you had 100 fish living in the area, and that concentration caused the death of 50% of the fish. That's a very, very low LD50. But if you had an LD50, like let's say it was 1,500 parts per billion, LD50, well, that's a chemical that's much less dangerous because you need so much more of it to kill the same amount of the population. So, like for example, caffeine has an LD50. You'd have to consume like 75 cups of coffee a day or 75 Red Bulls in order to get enough caffeine to cause death in you. But that actually has an LD50 because caffeine is something that doesn't occur naturally in your body. So it's a pollutant. And so just keeping that in mind, you have to really, really look at what are the kinds of things that are going to cause toxicity and this term LD50 in a population. And again, there's some nasty, nasty chemicals out there, and I'll get you to do some research on them in the project in this unit. And that's it for this part of lesson 4. I want to talk in the next video is going to be about measuring chemicals and what parts per million, parts per billion, etc. means. So stay tuned for part 2 of lesson 4.